In this video, we will continue coding our screen class, and it is now time to address the stack management methods that will let us interact with screens. So we'll jump right in here to the push screen method. Now again, this method is going to need to take in a name, see if it's in the dictionary, and if it is in the dictionary of all available screens, push it onto the stack to indicate that it is now a used screen, and that will begin our ordering or our stack history. So the first thing that we're going to need to do inside a push screen is to do that dictionary lookup. And we also have to be ready for the case where a name may be passed in that doesn't match any existing screen. So we'll have to be careful when we get the value out of the dictionary to make sure that it really does exist. So what we'll do is we'll make a local variable here called screen. So it'll be of type screen, and the name will be screen. The idea is that we will use the try_get_value method on our screens dictionary and use that to load out a specific screen into this screen variable. And then we'll also leverage the return value of try_get_value to see whether or not we need to continue with this screen push operation.
Okay.
So we'll start an if statement, and we'll say if screens, where screens is our all available dictionary, where screens.try_get_value. And then we need to drop in the key of the value we're looking for. That is screen name. And then if that name is found, we'll pass that value out to the screen local variable. So that finishes up our call to try_get_value and to our if statement. And we'll drop in some braces. Now, before we code the internals here, actually never mind, these start out very simple. If that did indeed work, then we should be able to take the newly found screen instance and push that onto the stack. So then we're free to address screen stack and tell it to push the item screen.
Easy enough.
And so really this is the heart of it. This is what we're getting at. It was just making this call to stack.push. Now we had already discussed how all screens are going to be given a notice as soon as they get shown. And we're viewing this action of being pushed to the top or pushed onto the top of the stack as being shown.
Right.
So we're also going to make a call to this screen instance's process show method. And we'll do that by calling screen.processShow. And again, we're hitting that protected method, which we can easily access here since we're coding inside of the screen class. But this is the idea that if we're coding inside of a screen and we ever get a call to process show, we know that this happened only because of the screen being shown by the system.
Very cool.
Now, if this name was not found in the screens dictionary, one, we already have our code set up to where it won't crash, because try_get_value will safely just notice that it's not there, won't return true, and we won't run any of this code. It would, however, be nice to show some form of error message. Make it easier to see that if we attempt to invoke a screen that doesn't exist, it would be nice to say as much. So we'll drop an else clause onto this if statement, and we will put in a simple log write line. And we'll use this to indicate that something went wrong. So what we'll do is we'll say, we'll say that screen argument 0 does not exist. And then the argument will simply be the screen name. That should be simple enough, excuse me, but should show that whenever, for example, we try to invoke a screen we haven't coded yet,
right,
or we have coded but simply haven't properly registered into that dictionary,
or heaven forbid misspelled.
Exactly. If we get any of these scenarios, we at least get an indicator back that where the system will say, hey, you tried to access a screen that doesn't seem to exist.
Right.
Now, one last thing we're going to do is we're going to prevent a form of what I'm going to term non-intuitive loop. With this idea of pushing screens onto the stack, there's no restriction put in place at this point to prevent someone from pushing a screen onto the stack twice. For example, if you had viewed the screen select, or the song selection screen, so that got put onto the stack. Then you continued to the game, so the game screen got put onto the stack. if you at that point pushed the song selection screen onto the stack, visually the game that could make sense in the game because that could look like you just exited the game screen.
Right. You want to choose another song.
But you want to choose another song. But if you push the selection screen on to the stack additional times, you run into a scenario where back would no longer make sense.
Right.
For example, let's say that in the course of playing 10 songs, you never popped any screens. You just continued to push the selection screen and then pushed the game screen again and then pushed the song selection screen again. You'd run into a scenario where when you're going forward, that would make sense. But the moment you tried to use the back button, it'd go from game back to select. That would make sense. But then if you hit the back button again, you'd be back in the game. And that wouldn't make sense.
Gotcha. Well, and this is where our back button functionality starts to deviate from that of something like a web browser. Right? Let's say, for example, you were browsing 3dbuzz.com, like there's some other site you could be browsing. Probably not. Let's just stick with 3dbuzz. And you've only got like 2 different pages that you're browsing on that site. If you just keep clicking back and forth between those 2 pages, you're going to build up a history of just those 2 pages. And as you keep hitting your back button, you'll have to keep jumping back through those pages over and over again. While that's fine for surfing the web, that would be very frustrating for a game. So you're playing the game and you're like, okay, I want to select another song. So you go back to the song selection screen, you choose another song, and you're like, okay, cool. Then you make the mistake of hitting back, which takes you to song selection. You say like, I'm going to go choose another mode of gameplay. So you hit back again. Now you're suddenly back in the game. That's a problem.
Right, and the way we're going to address that is for the purposes of the drum game as we've laid it out, we've never found a need to put the same screen into the stack multiple times, so we're just going to prevent that from the onset. We're going to do a check on the stack and make sure that the screen isn't already on the stack before we try to push it.
Okay.
So we'll do a simple if statement here, and we'll say if screenStack.contains, and then pass in the current screen instance. So if we do contain this, if we already contain this screen, then what we'll do is we will show an error message and then return out of the method altogether. So we'll basically just abort the push operation.
Now, technically, because we don't have like a whole bunch of links on the screen that a player can use to jump straight from one screen to another, since our flow is fairly linear, that should, if all things are working properly, we shouldn't be able to actually add the select screen a second time anyway, right?
Right. It's just to make sure in a way, it's kind of a help to us as a designer.
Yeah.
Because if instead of getting this invisible and hard to detect scenario of the screens getting added multiple times, if instead we get an error message saying that, hey, we shouldn't do that, that might be an indicator that our code flow is.
Oh, absolutely. I mean, I totally. I'm glad we have like a check and balance in place. What I'm saying is that if we did run into a situation where we really were restacking, because of the linear nature of our screen placement in the stack in the first place, that would mean that something is going on that's really wrong at that point.
Right, and we're just making sure that we prevent that, because you're absolutely right. As for the purposes of the game, we could leave the checkout altogether, and then from there on out,
we'd probably be okay if we coded everything properly.
Right, and then if we just make sure we code everything correctly. But in actual programming, of course, that's not necessarily a guarantee.
Exactly.
So it's nice to have this simple check in place. So if we ran into a scenario where we're about to double stack a single screen, what we'll do is we'll just write out a simple error message that says attempted to push argument 0, which is already on the stack.
That 0 doesn't need to be in single quotes, does it?
We could just phrase it a little bit better to say that, and this is an item we're looking at. And then to this we'll drop in the screen name, just to give ourselves some intelligible reason for what's going on. And then of course we need to remember to return at this point, so that if we return out of the method, then we will avoid running the actual push and process show commands.
Right. Again, so that's just a check and balance. If all things were working correctly, we probably wouldn't need it. But at the same time, if you were coding a slightly different kind of game, where as opposed to a straight linear progression of screens, you gave the player the ability to jump straight from one screen to another, this would be where you'd start to open up some interesting stack management. So you'd have to look into the screen, see where whatever screen you were looking for existed, and then actually start popping things off the stack until you got down to what you were looking for. We're not doing that in this case, but that'd be kind of where you'd have to start.
Exactly. At that point, you start to get into more complex trees of navigation.
Yeah, which is what we're trying to avoid.
All right, but that with our check and balance system in place and our functionality in place, that will take care of push screen. Now we can move on to pop screen. And pop screen is a good bit more simplistic. The actual code is just a few statements. The real thing that we're trying to put together is just to take whatever the current screen is and remove it. So really, this could be as simple as screen stack dot pop, and that would indeed take care of getting rid of the current screen.
Mm-hmm.
The problem is the pop method does not actually return, or excuse me, does return the screen being removed, and we still need to invoke this process show method.
Right.
So rather than just getting rid of it, we need to tell it that it's being gotten rid of. So what we're going to do is we're actually going to make a local variable here called screen.
Or of type screen.
Of type screen. We'll call this last screen. And so what we'll do is we'll pop the current screen. But what's interesting is we'll pop the current screen and then store it in last screen. The idea is that as soon as this statement is run, the current screen is no longer current.
Mm-hmm.
The moment we run pop, the screen below it is now current. So at this point in time, we can address the current screen by looking at active screen. So we can say active screen dot process show. Because the idea is that if we've just removed a screen from the stack, the screen below it has become visible.
Right.
And we need to tell it that, oh, by the way, you better get ready to be shown because you've just become visible again. And we also want to put in a call so that the screen that we just popped will make sure that it gets its call to process hide. So we'll say last screen dot process hide. So again, what makes this a little bit tricky to think about is the fact that you're almost thinking in terms of time travel, because the current screen becomes the last screen.
Yeah.
The current screen needs to be addressed, and the last screen need to be addressed at the same time, so the appropriate one can be hidden, and then the new one can be shown.
Right. It makes sense. It's just kind of an interesting progression. And what happens if they try to take the main screen off the stack?
Well, since we always have to have something to show, just like in the case of the sound engines, we always have to have a sound engine there, even if it doesn't do anything.
Right.
We'll have the same rule in place on the screen system. We always have to have a screen, otherwise we don't have anything to update and to draw and so forth.
Sure.
So we want to make sure that we never actually remove the last screen. We never want to completely empty that screen stack. So what we'll do is a simple check to see if this current screen is the only screen.
Mm-hmm.
And if that's the case, then we will abort out of the pop operation altogether. So we'll do this as a simple check where we look at the screen stack's count. If that count is currently equal to 1, meaning we're only containing one screen, then we'll know that, well, that's the only thing on the stack, so we're not going to remove it from the stack. As a matter of fact, instead, we're going to write out a simple error message. And so we'll do a log write line, and we will say that we attempted to pop the last screen. Now again, this is another one of those scenarios that we should never get into if we code everything correctly.
Right.
But this just acts as an indicator where if we're wondering why some screen, like for example, you're at the song selection screen, you're trying to figure out why you can't get back from the song selection screen. And maybe that's because somehow the main screen got taken off or put in the wrong order. Whereas it just gives you an indication of, okay, we ran out of screens. So let's see here. I guess we don't even need any formatting arguments. We're not going to worry about what screen that is. We'll just say that we couldn't do the operation. We will, of course, also do a return from this point, make sure that we abort out and don't run these following lines. And really that takes care of pop screen. So now we can move on to return to root. And return to root's job is to simply go through and pop every screen currently on the stack except for the last one. So we'll put together a while loop. We'll say while screen stack dot count is greater than 1. As long as we have more than one screen still on the stack, then we will tell our screen stack to pop the current screen. So it's kind of like, this was kind of like a jump to origin. So we don't follow the normal path of screen by screen getting pushed or screen by screen getting removed. We simply, it's almost like we jump just back to the original.
Gotcha.
Now with that, we have all of our static methods, that is, all of our screen management methods put into place. So before we continue on here, I think we'll call the video at this point.
All right.
And we'll see you in the next video.